This is our Earth, where we live. It has everything we need for our survival. And this is our sun, which is the reason why life exists on our Earth. If it was a little farther or closer to us, maybe there would be no life on our planet. Our sun is also like the millions of stars that we see in the night sky. The only difference is that it is very close to us, while those twinkling stars are very far away. If you are interested in space, you might know that these stars also have a life cycle, which means they are born and they die. And since our sun is also a star, it will also die one day. But the question is, what will happen to it before it dies? Will we be able to see it dying, or will life on Earth end before that? Let's take a brief look at the life cycle of a star. A star's life begins with the formation of clouds of hydrogen and helium in the galaxy. These clouds are called stellar nebulae. When a cloud of hydrogen in the galaxy becomes very large, it starts to collapse under its own gravity and begins to contract, heat up, and break up into smaller fragments that give birth to the young star. This stage of a star is called a protostar. Its core is dense, so it is also called an embryo star. As the protostar contracts, the gas particles inside it collide with each other more frequently, which increases the internal temperature. As a result, hydrogen atoms fuse into helium nuclei. This process releases a lot of energy in the form of radiation, which increases the pressure and temperature inside the star. This stage is called a star. In this way, two forces start to work inside the star. One is the gravitational force, which causes compression. The other is the fusion reaction, which releases energy that pushes outward and opposes compression. These two forces remain in balance for billions of years. This is the longest phase of a star's life, called the main sequence. If the second force does not occur, the star would collapse within 30 minutes of its formation due to its immense gravitational force. The star's core consists of 70% hydrogen, 28% helium, 1.5% carbon, nitrogen, and neon, and 0.5% iron and other elements. After spending a long time in the main sequence, the star starts to run out of hydrogen fuel in its core. The core contracts and heats up, while the outer layers expand and cool down. The star becomes a red giant or a red supergiant, depending on its initial mass. The red giant is much larger and brighter than the main sequence star, but also cooler on the surface. The red supergiant is even larger and brighter, but also more unstable and prone to violent eruptions. In the core of the red giant or supergiant, helium atoms fuse into carbon and oxygen. This process releases more energy and increases the pressure and temperature inside the star. The star may also start to fuse heavier elements like neon, magnesium, silicon, and sulfur until it reaches iron. Iron is the most stable element and cannot release any more energy by fusion. The star's core becomes an iron ball, surrounded by layers of different elements. When the iron core reaches a critical mass, it can no longer support itself against gravity and collapses in a fraction of a second. This triggers a massive explosion called a supernova, which blows away the outer layers of the star and releases a huge amount of light and energy. The supernova can outshine an entire galaxy for a few days or weeks. The fate of the star after the supernova depends on its initial mass. If the star was less than 10 times the mass of the sun, the core will become a dense ball of neutrons, called a neutron star. A neutron star is about 20 kilometers in diameter, but has a mass of about 1.4 times the sun. A neutron star spins very fast and emits beams of radiation from its poles, which can be detected as pulses of light or radio waves. This type of neutron star is called a pulsar. If the star was more than 10 times the mass of the sun, the core will become so dense that not even light can escape from it. This is called a black hole. A black hole is a region of space where gravity is so strong that nothing can get out, not even light. A black hole has a point of no return, called the event horizon. which marks the boundary of the black hole. Anything that crosses the event horizon is doomed to fall into the black hole and never come back. Now, let's come back to our sun. Our sun is a medium-sized star, which means it will not end up as a neutron star or a black hole. It will become a red giant in about 5 billion years, and then a white dwarf in about 8 billion years. A white dwarf is a small, dim, and hot star that slowly cools down over time. It is the final stage of a low-mass star's life. But what will happen to our Earth when the sun becomes a red giant? Well, the bad news is that our planet will not survive. As the sun expands, it will engulf the inner planets, including Mercury, Venus, and Earth. The Earth will be vaporized by the intense heat and radiation of the sun. Life on Earth will end long before that, as the sun becomes brighter and hotter, making the Earth too hot and dry for any living thing. So, we have seen how stars are born, live, and die. They are the source of light and heat for many planets, and also the source of many elements that make up our bodies and our world. They are fascinating and beautiful, but also powerful and destructive. They are the ultimate example of the cycle of creation and destruction in the universe. I hope you enjoyed this video. If you did, please like, share, and subscribe to our channel. And don't forget to comment below with your thoughts and questions. Thank you for watching.